OA1. Go ahead and write OA1 down. And this is all in quarter one. This is what they're doing right now. They're in the thick of this too, okay? Huh? Oh, a pencil? Yeah, there's more pencils. There's pencils over here. Sorry. Let's see if we, there we go. Perfect. You could brush your notebook and everything. So studious. Love it. She is prepared. Go pull your name up. Awesome. All right. So OA1, use parentheses, brackets, or braces. Now, you see your or there, okay? They're going to have parentheses and a problem, or they could have brackets, or they could have braces. So here's an example, okay? Here we've got our parentheses, right? So they have to know what that truly means, right? Well, what does parentheses mean? They have to do what? Do that first. That's right. So they're going to do this, and then they're going to get their number, and then divide by this number, okay? Or divide by the 6 and then plus the 2, all right? So they have to know what these things mean, okay? And do problems with those in it, all right? So as much as you can give them at home of these examples, that would be great, okay? OA2, write simple expressions, all right? Now, this is like algebraic expressions. So I'm going to give you an example of what they would need to be able to write, okay? Lee worked 7 hours for N days. Write an expression for how many hours Lee worked. Okay, so here's their little expression, 7 times N. Right? 7 hours for N days. Well, that's going to give you the total of how many hours he worked. Okay? So that's just an expression. Okay, they're not finding out the true answer, right? But they're writing the expression of how to find out the true answer. Okay? And like I said, you can write the examples down, anything that you need to work on this at home. NBT 1. A digit is 10 times as much to the right and 1/10 of what it is to the left. Now, they've done this in 4th grade. They did the 10 times as much place value all the way to the thousands place. But now what they're adding on is they're adding on their decimal points, okay? Because they didn't do that in 4th grade. So here's an example. So explain the relationship of the 5s in this number. 455,721. Well, we know that the 5 in the 10,000 place, right, is 10 times more than the 5 in the thousands place. And here you could write it out. 50,000 is 10 times more than 5,000. Right? So it's the relationship between the place value, going from, you know, even they have to know all of this from the ones all the way up to the 100,000s. Okay? They're also going down to the tenths place with decimals. Okay? So that could also be 755,000 or 455,721 and 4/10. Okay, they can go down to the tenths place, and they have to know that relationship as well. Okay, hey, how's it going? So we're just writing the standard, and you don't have to write all this stuff beside it. You're just writing notes on what you hear me say that will help your child at home. You can write the example, or you can just write things that you kind of pick up and say, oh yeah, we need to do that at home. Tell them out, okay?
Okay.
I'm just showing you an abbreviated version of the standard, things that the meat of the standard that you need to know, and then what they're doing in class, an example of that standard, okay? All right. So NBT 2, the powers of 10, okay? Now these are our powers, our exponents, right? So there's an example. 30, they're only doing this in tens, okay? They'll just do the 10, the power of 10. 34 times 10 to the second would be the same as 3,400 equals 34 times 100, right? All of that is the same thing, okay? Another example, 34 times 1,000 equals 34 times 10 to the third. Okay? They need to know the relationship of all of those. This expression, this, and this is all the same thing. Okay? They're powers of 10. And you can, I mean, a lot of them, they know the trick, right? If they're gonna do this, they just add two what? 2 zeros, right? But really make them talk about the place value and why that's true, okay? It's 10 times 10, all right? This is 10 to the second, that's what it is, 10 times 10, so that's 100, okay? So really have them talk about that place value before they just say, oh, I just add two zeros, okay? Have them know the knowledge of why you're just adding 2 zeros, yeah. NBT 5, this is multiplication using the standard algorithm. If you want to cheer, if you want to chant, you can do that right now. Okay. Anybody excited that they get to finally use the standard algorithm? Okay. You can with this one standard, you can use old school math. Okay. This one standard. So NBT 5 is our regular way to multiply with just multiplication, not division, but multiplication. Yes, the standard algorithm for multiplication. There it is. We all know it, right? It is taken all the way to 5th grade, and now we finally get to it. Okay. So because in 4th grade they had to do area model, okay, for multiplication. So you saw all the blocks come home, right? They're drawing big squares. They're doing their place value. So after doing that, for a whole year, we're hoping you've got a good sense of place value and why this works, right? So now they can do this, right? So the 5th grade teachers are like, all right, we're finally to standard. All right, so NBT 6, fluently divide a 4-digit by a 4-digit, okay? So it's up to a 4-digit. Right now they might see something like this, okay, a 2-digit by a 4-digit at the beginning, because for 4th grade they did a 1-digit by a 4-digit. So now they might be gradually going into here. Now, do you see the standard algorithm?
Yeah.
Well, is this standard algorithm?
No.
No, it's not. It's not. Not with division, okay? So what they want them to use is partial quotients. Now, maybe you learned it this way and you think this is the standard algorithm. If you did, fantastic, okay? This is not truly the standard algorithm for division. It's not long division. Right, this is a partial quotient. So let me show you what they're really doing, okay? So, you got it? Oh, did it? Okay. Yeah. So it doesn't matter. This is not the perfect way to do it. Your child might think of something else. This is just how my brain works. But they might think of other numbers that's going to be over here, but we're all coming up to this answer, okay? Like instead, just for example, they might say, I want to do 2 100s instead of 200. Maybe if they couldn't see the 200, like they just couldn't process that in their brain. So they're like, I'm going to do 12 times 100 and get my answer, and then 12 times 100 again, and they're just going to have one more step than me. That's fine. That's how their brain works. Okay, that's fine. Okay. So I just saw the 12 times the 2 because I mean I know my facts, and they should know their facts by this point to 12. But if they don't, it's okay. But if they do, then they're going to see, okay, 12 times 2, I know that's 24, right? So that 12 times 200 is going to give me 2400. I'm going to subtract it down. Now I get to 810. And then I'm like, I'm just going to do about 12 times 5, because I know 12 times 5 is 60. Just 12 times, and then 12 times 50 is going to be about 600. I'm going to subtract it down again. And so now I see I've got to get to 210. So I'm just thinking by that point, I know 12 times 12 is 144, because I just know that fact. You know, that's all I know pretty much. Memorized is 12. So like 12 times 12,
This is crazy. I like it though.
they don't have to do it like, you see what I'm saying? Like they could do like 12 times 10 and then another 12 times 2. You see what I'm saying? However they think through it to go ahead and get rid of this number all the way down, right? So then I get all the way down, I have my remainder of 6, and all they've got to do is add these numbers up. That's it. And then there's their answer. You see what I'm saying?
Yeah.
So for them, it is truly easier to do it this way. It really is. The long division throws them off. They do not, it's until they just memorize a process, they know what they're doing, but they're just memorizing it.
Yeah.
Okay. All right. So we're trying to get rid of this big number, right? So we're seeing how we can, what is going to multiply by what to give me a product that's big enough to just subtract it all the way down to get rid of this, right? Same thing you do with long division. Same thing. That's what we're really doing, right? We just don't write it down this way, right? We're trying to think of what can I multiply into this, right? We break it down into, we used to say 12 into 32, right? And you're seeing how you can, yes. But really, that's not true. You're not seeing what 12 into 32, really, you know? Let's break it down into place value so that they can see what they're really doing. So 12 times 200 is going to give me what? 2,400.
So we got the 200 from 210 out of the 3,200.
We got the 200 because I thought, what can I multiply that's big enough,
Oh.
that's gonna give me a number, that's gonna try to get this number down quick.
So we're doing long division with 0 of that right there. Okay, I'll stop.
Really, with place value, with place value,
Okay,
yeah, with place value. That's what you're doing.
gotcha.
Mhm. Yeah, you're trying to think what is gonna give you the biggest number at the beginning. That's what I do anyway. It's gonna give my biggest number here, then I'll just keep going down here. But your child, like I said, they might not think of 200 right away.
Yeah.
That's okay, you know? So if they think of 100 first, they're just gonna have one more step. That's okay, all right? And then after they keep doing this over and over, they're gonna be like, no, I know that 2 times 12 is 24, 24, so I can do 12 times 200. It's gonna give me 2,400. That's gonna be, quicker for me, and they'll get faster at it. Okay, they've been doing this for 4th grade. Okay, 4th grade did this. They just did a 1-digit by 4-digit. They didn't do a 4-digit by 4-digit. Okay, so make a little more sense. You'll write it down. Okay. If you need some more practice, you can go to learnzillion.com.
No.
It's a free Learn Zillion. And you can type in partial quotients, and they will give you many examples. Okay?
What do you say, partial?
Partial quotients is what it's called. And they'll give you many examples of it, okay? You like it? Yeah. I like it. But now you like it? Oh, okay, good. I'm glad you do. I'm glad somebody, getting something from somebody. All right, it's late, people, I need something. All right, NVT 3, read, write, and compare decimals. All right, so here we have our decimals. Remember, we're gonna go to the tenths. This is to the hundredths, okay? But when they're on that last standard, when I said that they had to compare, what was it? NVT. Well, yeah. This is just your place value. So you can obviously this is expanded form, but all the way down to their hundredths, okay? So 3 times 100 obviously is their 300, right? 4 times 10 is their 40. 2 times 1 is their 2. 9 times 1/10, because this is their tenths, right? This is their hundredths, and this is their thousandths. You got that? That's just expanded form, okay? Easy peasy. You're like, I got this. All right. So here's an example of them comparing all the way down to their thousandths. 342 and 931 thousandths compared to 342 and 831 thousandths, okay? We always teach them to start at their highest place value, right? These have the same highest place value. What throws them off sometimes is what if I didn't have that and I had a 42? And then I said, okay, start at the highest place value. What do you think some kids are gonna do? Put their finger into the 4, put their finger into the 3. Is that the same place value? No, it's not, okay? So they have to make sure they have a good sense of, nope, that's a 10. That's a 10. Okay, you're in the tens place. Over here, this is the hundreds, all right? But with this number, okay, we have the same, we start same highest place value, which is the hundreds. So we'll start there, that's the same, right? Go to our tens, that's the same. Go to our ones, that's the same. Now we go to our decimals. All right, here in our tenths, oh, there's where it changes. So if I have 9 tenths compared to 8 tenths, we know that this number is greater. Okay? They go all the way down to the thousandths. Okay?
Is there a website for this?
For your frameworks,
Yes.
it is, let me see where you can, because that's Cobb County. That's not state.
Okay.
Do you need it? Do you need me to?
Well,
send-
I have to go figure out about it.
Oh,
So, I
okay.
wrote down the NVT stuff.
Okay,
What other
and this will be
ones?
on our website, honey, they're filming me right now. So
Okay.
this will be hosted on just Powers Ferry's website. So
Got
go to
it.
Powers Ferry, and you can fast forward through all this, and now she's gonna watch, starting right now.
I have to wait till she's finished.
All right, so round decimals to hundredths place. Here is all the way down to you see our thousandths here, and then they're gonna round to the hundredth place. They're not rounding to the thousandths, obviously that wouldn't make sense, right? Because they're not going past the thousandths. But, to the hundredths, so 462 and 9/24 thousandths, rounded to the hundredths place. So we're looking at the thousandths, right? If we're gonna round to the hundredths place, because you always gotta look one before, right? So if it has a 4, are we rounding up? No, we're not, right? And we teach them, some teachers say high five. If it's 5 or more, you're going up, so give me a high five. So it's not, so they're going to stay the same. So 462 and 92 hundredths, okay, is what they're going to stay at. Example. NBT 7, add, subtract, multiply, and divide decimals. Here's where it gets fun. You excited? Okay, enough. That's where it gets fun. All right, so we are going to do 2, not say point, by the way. I have to watch my text. So 2 4/10 divided by 4, and we're going to use base 10 blocks. Okay, so I'm going to show you how that looks. All right. So they're using these as wholes. Okay. All right. Let me get back over here. Everybody can see. All right. So you tell me what I'm starting with. I'm just starting with 2 and what? What's our problem start with? 2 and 4 what? What is that? 2 and 4/10, right? Good job. 2 and 4/10. Star to you. So here is our tenths. Now, up until this point, this is 100 for them, okay? But what we're using this for is, it's on the tenth system. So this is now, these are now their tenths, not their tens, they're tenths, just so they can see it and visualize what this really is, okay? So here's 2 wholes, okay? And then 4/10, right? And now it's asking us to divide that by 4. And how many are you going to have, right? So what we do is we put this together, and I say 1, 2, 3, 4, 5, 6. That's 1.
Fourth and fifth grade parents, I want to thank you again for coming out for our Math Mania this session. The session is now over, and I want to also say that you have been a support to our students, and our 4th and 5th grade students need that support, and we really appreciate it.
Okay.
Have a good evening, and we will see you at PTA Open House coming up.
Okay, I'm going to keep going. All right, so let me show you how they would do this. So we need to know to divided by 4, so we need to know how many times we can do that, right? So let's see, how many 4s do we have in there, right? So 1, 2, 3, 4, we're going to stop there. That's how many? 1, right? 1, 2, 3, 4, we're going to stop there. How many is that? 2. 1, 2, 3, 4, how many is that? 3. 1, 2, 3, 4, how many is that? 4. 1, 2, 3, 4, how many is that? 5. And 1, 2, 3, 4, how many is that? 6. So we have 6 tenths in the 2 and 4/10, right? If we divide it by 4, that's how many tenths we have, right? We have 6 tenths, okay? See how that would make sense to them instead of just doing some kind of standard algorithm and figuring this out, okay? They can visually see, like, these are little tenths. How many do I have in that number, right? And so then they do this out, and they can draw this out. In class, they use this concretely first, and then they get to where they can draw it out, okay? Now, that's the division piece. Here's the multiplication piece, okay? Now you've seen it on concrete right here. This is how it looks drawn out, okay? So 2 and 3/10 times 1 and 4/10. Here's my 2 wholes, right? With my 3. Now you might want to draw this out, okay, if you want to, okay? So 2 and 3/10. Here's my 3/10 right over here, right? Just like we talked about. So this will look like this. Here's 2 and 3/10, right? That's that number. You got it? Okay. Now we're going to multiply it by 1 and 4/10. Now, we're multiplying, okay? I'm going down this way. I already have a 1, don't I? I already have a hole right here. So it's really this, 1, I'm multiplying this. And then it's 1 and, what did I have? 4/10. 4/10. Okay, and they do this, they build it. Okay, and then we fill it in with the rest of the tenths that we need. So we're gonna fill it in, and I promise this works, y'all, don't look at me crazy. It does. So we're filling in with our tenths, right? Then what do you think we need right here to fill in this? Our hundredths. So then we're filling in all this space with hundredths, okay? And y'all know what I'm doing, so I don't have to build it. If y'all were kids, I'll build it with you. Okay, so here's our hundredths right here. So then all they do is they say, okay, here's my 2, plus my 8/10, which is right here, right? 1, 2, 3, 4, 5, 6, 7, 8. There's my 8/10, plus another 3/10, which is over here, right? And then my 12 hundredths, which is all right here, is going to equal 3 and 22 hundredths.
Okay, go over that last part you
Okay.
said, please.
Sure will. All this?
Yeah.
Yeah, okay. So here's my 2 holes, right? Right here. Because I said 2 and 3/10, right? So here's my 2 holes. Then I've got to add in my 8/10, or here's, you see these right here? Which are these guys, right? My little tenths. Right here, perfect. Okay? But then I had 3 more tenths over here, didn't I? So I had these over here that I'm having to add in, right? And then I have these 12 hundredths, which are my little bitty ones, right? And if I add all of that together, right, because then I'm getting 3 and 22 hundredths.
Yeah.
Yeah. Cool, huh? Yeah. Okay. And then they can draw that anywhere, okay? When they get good with seeing what's going on, they can draw this anywhere, and there's their visual representation. You know how their standard says, or their rubric when they're trying to solve problems, it says, you know, it has to have a visual representation in there. There you go. Okay? They can do that anywhere. So now you can. Okay?
Yep.
All right. I know you're going to be going home drawing this. I seriously do. I bet
I
you're going to be
already
going.
did.
Because when I first learned it, I was like sitting there drawing out
Yeah.
tons of decimals just to make sure it worked. And then I'm with my calculator making sure, I'm like, make sure this answer's right, right?
I even
So-
put arrows by them so I can understand it.
Yeah, okay, good. Whatever you need. I'll give you this whole chart if you need it. And take it home. All right, so quarter 2, and I'm going to go really fast. I know you don't want to stay here forever. NF1, add and subtract fractions with unlike denominators. So here we go. They're making sure that there are like denominators, and then they're adding them together to get their final answer, okay? NF2, I think I said NF2 up here, NF1. NF2, add, subtract fractions in a word problem. So here we go, we're adding our fractions into a word problem, all right? A worker has carpeted 8 7/12 feet of a hallway. The hallway is 18 3/4 feet long. How many feet of the hallway still needs carpet? So what do we need to do to those fractions? We've got to subtract them, right? Okay, so 18 3/4 minus 8 7/12. Here we go, we create our common denominator. Go ahead.
I'm doing this the smart way.
Go right ahead. There's no shame in the game. So they're creating their common denominator or multiplying by something that they can create, right? So we have the 4, we're 4, multiplying that by the 3, by the 1, because we just want to use the 12, right? So now we get our final answer of 10 2/12, and we're going to reduce that to 10 1/6.
Yeah, because
Okay.
you're just breaking it down.